The last thing we're going to do in this section is talk about higher order derivatives, right? Because the derivative is a function, right? You take the derivative of a function, you get a new function, and we could take the derivative of that, right? And we'll get another new function, take the derivative of that, we get another new function. So we can take derivatives of derivatives, and those are called higher order derivatives. So the second derivative is the derivative of the derivative. All right, so here basically showing you the notation. We use a double prime, f double prime of x, right? That's the second derivative. Or using the Leibniz notation, we can write d2y over dx squared. Okay, so that's just the notation. If we take the derivative of the second derivative, we get the third derivative. And so again, the notation, we use these little prime, prime, and then use the d3y over dx cubed. So now anything higher than the third derivative, it's just too cumbersome to use all those prime symbols. So what we do is we put the number, the number of the derivative in parentheses. Like here it's the nth derivative, right? This little n in parentheses denotes that it's the nth derivative of x. Or we can use the Leibniz notation. All right, so let's do this example. Shouldn't be too bad. So we have this function, x to the fourth plus 2e to the x. So let's go ahead and do the first derivative. We're just going to use the power rule. Bring down the 4. We get 4x cubed plus 2e to the x, right? This is a constant multiple of the e to the x function. All right. So the second derivative is just the derivative of the derivative. So we're going to get 12x squared, but then 2e to the x, right? It's just a constant multiple of the derivative of e to the x, which is e to the x. So, all right, so we can keep going. The third derivative, we take the derivative of the second derivative, and we get 24x plus 2e to the x. All right. Now, notice the notation is switching here. After the third derivative, we're just using the number in parentheses to denote the which derivative, the order of the derivative. So take the derivative of 24x, we're just going to get 24. And the derivative of 2e to the x is always 2e to the x. And then the fifth derivative, all right? Take the derivative of the fourth derivative, you get the fifth derivative. Now that 24 is just a constant. So now we're all we have left is 2e to the x, because the derivative of 2e to the x is 2e to the x. And any other higher order derivatives, like if I was going to do the sixth derivative, it would just be 2e to the x. The seventh derivative would be 2e to the x. So from here on, it's pretty stable. It's just going to stay. All the derivatives are going to be 2e to the x. So, all right. So that is that's all I have for this section, and I will see you in class.